PhaseSpace makes the future. We have one of the funnest jobs in the world. We've been working on virtual reality for over 30 years. The interesting thing is we keep revisiting the problem, and it's gotten better every iteration, every generation.
PhaseSpace is a platform to make VR the way I wanted to make VR. Some other companies have tried using other tracking technologies that use passive markers. Some of them use other integrated methods. But PhaseSpace is truly the only one that I've found that can do what I want to do.
We're able to put you inside of a virtual world that is utterly realistic. The key, though, is to not take you out of the experience. To do that, we have to try tricks that require an amazing amount of computational horsepower. We are actually tracking the user 960 times per second down to 50 micron resolution. That's completely beyond any standard video technology. That additional data allows us to do high dynamic range and better compression and other tricks that wouldn't be possible and that the competition can't do because they're using off-the-shelf ASICs that only do one thing.
Because of PhaseSpace's active marker technology and extremely fast tracking, we can get as many people as we want in the space, which is what I want out of VR. I want people to experience VR together.
So in our typical configuration, we'll have 48 cameras, each one with a Xilinx Spartan 6 FPGA inside, doing the algorithm on board. And that allows us to actually daisy chain up to 8 cameras on a single cable. The Xilinx processors give us the flexibility to do different things in different ways and take advantage of the unique capabilities of the new sensors.
I see you.
So now we've got a pretty amazing solution that everybody's been going through and saying they're not dizzy or nauseated, and I think that's a pretty good sign.
And we've customized the Xilinx FPGA so that it can be doing the processing and making it a distributed processing solution, because now instead of having some super centralized processor trying to handle the data from 48 cameras, we have 48 FPGAs doing local processing and then send the data down daisy chain, making it much more efficient, much easier to set up, and much faster.
Any layer of abstraction that allows me to write in a language that I'm already comfortable with that can just be ported into running on chip or in hardware, it would literally cut development time in half or even faster to be able to go straight from C into something that functioned in hardware.
Using the Xilinx processors for over 15 years now, we've been able to make custom solutions that then we can mass produce.